So how do we write scientific notation numbers? So in the front, you have what's called your coefficient, which is a number between 1 and 9. So it is only a single digit number, it's not two digit. And then you have times 10 to the power of an exponent. Now, this is not a mathematical expression. It's a way of saying that this is a large number or a very small number. So this exponent tells you how much you've moved the decimal either left or right. So if it's positive, that means that the number was really large. So a positive exponent means that the number was large. Okay. So for example, the number 3,200 with a decimal at the end, I'm going to move it over and the decimal point over until I get a single digit. So I'm moving it over once, twice, then 3 times to get it to be 3.2. And now because I moved the decimal over 3 times, it's raised to the third power. So this isn't a really huge number, but it's just to show you. So normally you would probably leave it as is, but I'm just showing you what scientific notation is. So it's 3.2 times 10 to the third. And so these numbers mean the same thing. If it's a negative exponent, so that means it's raised to a negative power, that means it was a really small number. So for example, 0.00086, same thing, we're just moving it to the right. So move it 1, 2, 3, 4 times, because that would be 8.6. So it would be 8.6 times 10 to the negative fourth. This is a small number. So now let's convert these back and forth. So this is in standard, so not scientific, so I need to put it in scientific notation. So here's my decimal. I'm moving it 1, 2, 3, 4 times. So it's going to be 9.53 times 10 to the negative fourth because it's a small number. Now this one is already in scientific notation, so I'm going to move it out. So I want to start writing here so you guys can kind of see. So it's 5.75, and you really won't convert you'll mostly convert this way, not the other way, but it's just to get you guys to understand what scientific notation actually is. It's a really large number. So I need to move it over 11 times. And since it's positive, I know I need to move the decimal over to the right. So I move it 1, 2, and now I have 9 decimal points to go. So I just start adding zeros. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this number would be 575 billion, right? Yep, billion. And so this is a lot easier to write like this. Now we have this number, which is 3.2 times 10 to the negative fourth. So now I'm going to move the decimal over to the left. So again, just to make it easier to see. So I'm moving it once. Well, I still have to move it 3 more times. So that means I'm going to add zeros in the front. So 1, 2, 3, 4. So there's my decimal point. I like putting a leading 0 before the decimal point so you understand it is a decimal. And now we're going to convert this into scientific notation. So even though there's not a decimal at the end, I know I can just put 1 right here. And then I start counting. So I'm moving it 1, 2, 3, 4, 5, 6, 7. And then I'm not stopping here because that means my coefficient is 2 numbers, 7, 8. So it's going to be 1.51 times 10 to the 8. We'll talk more about why I keep the coefficients numbers there, but I dropped the zeros on our lecture on Wednesday, Thursday. If I was here, I would have you guys work on this as a group, but I just want to go over more examples just for you guys can see. So this is a standard number. So I'm going to move it into scientific notation. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 5.5 times 10 to the 11th. This one is 1.28 times 10 to the 7th. So again, I'm just going to write it here because it makes it a little bit easier. So I'm moving it 1, 2, and then I have to move it 5 more times. So 3, 4, 5, 6, 7. I think that's what the number zeros. Yep. And then moving average volume of blood pumped per day, so 8,500 liters. So you move it over 1, 2, 3. So 8.5 times 10 to the third. This one is 5 times 10 to the second, so it's actually 500 seconds. Mass of the typical human ear. You're just moving this over once. Again, you wouldn't really do this because this is actually longer than this one, but again, it's just practice. 3, and then the negative third tells you it's small, so you move it 1, and then 2, and then 3. 3 grams. Diameter of chickenpox, so 1, 2, 3, 4, 5, 6, 7 to get that. So it's 3 times 10 to the negative 7th because it's a very small number. And this one, it's going to be 18 zeros followed by a 1. So 1, 2, 3, 4. Which is why it's a lot easier to write this one. Now, ours will actually, most of our numbers are going to be to the 23rd power and above. So that's why instead of trying to keep track of all these zeros, especially when you do calculations, it's a lot easier just to tell the calculator to use the